Key indicators. What are key indicators? Key indicators in this situation are things that are indicative of an over-normalized database that may require denormalization to help speed up its performance. All I'm going to do at this stage is just mention what they are. One-to-one relationships. Generally fourth normal form, perhaps dividing tables up much too far, creating very large SQL statements on multiple table joins. Many-to-many join entities. Look for many-to-many join entities which have a name which is not meaningful. Over-normalized static data. Static data can be removed from transactional data sometimes a little bit too far. I like to think of normalized static data as second normal form. Tables with a very small number of columns, very few columns, quite often indicates a table which could have its columns in a parent table. It shouldn't really exist. Fourth normal form denormalization. My key indicator here would be one-to-one joins. This is a one-to-one join, so is this. What I've done is I've denormalized one of the one-to-one joins, namely the listed entity, and then I've denormalized the address one-to-one join. Everything ends up in the customer table. Why would you want to do this? Because the SQL statement here would look at 3 tables, and in this case it would look at 1 table. Fourth normal form attempts to remove potentially nullable objects such as the customer address detail and the stock market ticker symbol from the customer object. In my mind, this is academic. It's not commercially practical. What actually happens is you remove these null objects from here. There's no need to do that because they're null. They don't take up any space. It creates a more complex table structure in fourth normal form, which is intelligent in terms of reducing complexity. Believe it or not, that does actually happen, but that is more sort of an object methodology rather than a relational methodology. There is no point in doing this. This is the much better form of the customer table. A SQL statement here would require a multiple table join on 3 tables. In this case, it would be against a single table. If you were to add all sorts of other information to a query, for instance, sales orders, sales invoices, purchase invoices, you could end up with huge joins which are very slow and impossible to tune. Meaningful third normal form. What do I mean by meaningful third normal form? Take this example. I have a database or a table structure which represents, for instance, pop concerts or pop acts doing many shows at many venues all over the country. They have supporting acts. Quite often, not always, but quite often. A supporting act is also an act. Therefore, the relationship between the act entity and the show entity is actually one-to-many or many-to-many. The many-to-many relationship between the act and the show entities can be resolved into a single entity called supporting act. It is meaningful. It has a name which makes sense. It says supporting act. Here's another many-to-many resolution join. I call this one meaningless because all we've done is we've taken the course entity and the student entity, placed them together and called it course student. We do not have a specific name for it that means something else other than course student. This is the type of many-to-many relationship that I look for, because quite often they're unnecessary. They're created because they exist, but they are not necessarily used by the application. Think about it. Let's say you have an application that will list courses, so you'll pick a course from that list and you'll get a list of students. So you could click a single student and get the information for that student on that particular course. The chances are you don't need to go to the database to select that information. It's already in memory in the application. The same would apply the other way around, where you would look through a list of students and find all the courses that they do, and then you could select an individual course for that particular student. If there's any information that's applicable to the course-student combination, it is probably already in memory. The only situation where an entity like this is needed is where there are extensive fields that are applicable to the course-student combination. It's unlikely. There is a many-to-many relationship between these two entities, but it doesn't necessarily have to exist. That's my point. Don't create many-to-many join resolution entities unless they're actually used. Second normal form denormalization. This is the fourth normal form example we used earlier. This is the same example, except we have the separation of a static item of data from the listed entity. What I've actually done is I've said that our customers, some of them will have ticker symbols, and they will be listed on a certain stock exchange. The point is this: how many records will be in this table? How many stock exchanges exist? Assuming we're looking at Fortune 500 customers, the chances are they're only going to be NYSE and perhaps the NASDAQ. There's no point in this entity existing because it'll have 1 or 2 records. Watch for that. Static entities with a very small number of records. That can cause problems because to read from the customer information to find his address, his listed object, plus the exchange information, you're reading from 4 tables. Practically all that information should be in a single table.